Hi, welcome to our next level 3 integration video. In this video, we're going to focus on a technique of integrating functions that have y dash over y, the derived function of y over y. Right, straight into examples. This is a very similar technique to the last video, integration by inspection, and it involves a little bit of observation, watching what's going on. All right, here's example 1. Let's integrate 2x divided by x squared minus 1 with respect to x. Well, the answer is natural log in the absolute brackets of x squared minus 1 plus c. Now, what the heck has just happened here? First of all, you know that when we integrate a 1 divided by a function x, we get the natural log of x plus c. So that's why we get the natural log of x squared minus 1. Because it's 1 divided by x squared minus 1. But you might be asking yourself, what's happened to the 2x? Let's show you what's happened. Let's take the function y equal to natural log of x squared minus 1 plus c, and let's differentiate. So, natural log of a function u turns into 1 over u, and then we must times by u dash, which is the derived function of u. Now, x squared minus 1 is u, and we differentiate that to get 2x, so we times by 2x. When we tidy that up, the c will disappear, remember, because any number by itself disappears. So when we tidy that up, we're going to get 2x over x squared minus 1, which is where this 2x came from. This 2x is just u dash. So when we integrate it, we don't need to put the u dash because the 2x will come there after we differentiate it. This is an idea where we have y dash over y. We have the derivative, which is 2x, over the y function, which is x squared minus 1. And whenever we get y dash over y, it integrates just to the natural log of the y function plus c. All right, let's go to example 2. We're going to use the same idea, y dash over y. This is a little trickier now. You'll see that we are going to integrate x over 4x squared minus 1 with respect to x. Now you're thinking the top function is not y dash because the bottom function is y, 4x squared minus 1. 4x squared differentiates to 8x. And on the top, I don't have an 8x. So here's a little trick we're going to do. We're going to multiply everything by 8 over 8. Multiplying by 8 over 8 doesn't change the question because 8 over 8 is just 1. But we can take the 8 on the top and multiply it by the x and leave the 1/8 out the front. So now we do have an 8x on the top, and 8x is the derivative of 4x squared. So we now have y dash over y. Now this will integrate to 1/8 times the natural log of 4x squared minus 1 plus c. So the 8x, we don't need to worry about that anymore because that is just u dash. And we've got the natural log of 4x squared minus 1, and we're timesing it all by 1/8. Little tricky, that one. Let's try another one and see if you follow that same idea. All right, example 3, let's integrate x squared over x cubed plus 1. Well, again, x squared is not y dash because x cubed differentiates to 3x squared. So there's no 3 on the top. But what we can do, once again, is multiply the top and bottom by 3 over 3. That means we now have 3x squared on the top, which is our y dash over y. So when we go to integrate it, we're going to be left with 1/3 times the natural log of x cubed plus 1 plus our constant c. Great, thanks for watching.